Question 1. Expand minus 3 outside of m plus 4. When we expand an expression, we multiply the front term by each of the terms inside the brackets. So we'll multiply the minus 3 times the m to make minus 3m, and then we'll multiply the minus 3 times the 4, and we'll get minus 12. We've got to keep them separate because they're not like terms. They don't have the same letter and power, so we can't sort of join them together. So minus 3m minus 12. Question 2. Expand and collect like terms on 3 plus 4 outside of y minus 2. Okay, to expand an expression, we multiply the front term by each of the terms inside the brackets. So we'll keep the 3 separate for now because the 3 is adding, and what the 4 is doing to the bracket is multiplying, and our order of operations says we've got to do multiplies before we do adding and subtracting, so we certainly do not add the 3 and the 4 before we do anything. First thing we do is a multiply before a plus, so let's expand that bracket first. So we'll just write the 3 there. We'll say plus 4 lots of y. We got 4y by multiplying the 4 out the front of the brackets by the first term, so that's just the first part of the expansion. Then we'll multiply the 4 by the second part of the brackets. 4 times minus 2 is minus 8. So be careful with that. We've got to do the expanding of the brackets before we worry about the 3. Alrighty, now I've got some like terms. It says you can only add and subtract like terms, and for like terms we kind of think of x's and y's and things like that, but normal numbers, if they're both normal numbers, they're just like terms with each other, and we can join normal numbers, as we know. So if we can concentrate on the 3 and the minus 8, we can join those two together to make minus 5, and we usually write the letter term first, so here we'll end up with 4y minus 5 once we've joined those normal numbers together. Question 3. Expand and collect like terms on the expression 3 outside of x plus 2 plus 2 outside of x plus 3. To expand an expression, we multiply the front term by each of the term inside the brackets. So at first here we get a 3 times an x, making 3x. Then a 3 times the 2 makes a 6, that's expanded the first bracket. Let's work on the second bracket now. We have a 2 times the x makes a 2x, and a 2 times the 3 makes a 6. Now you can see that we've got 2 x terms and 2 normal numbers, so we can do some collecting of like terms here. We can only add and subtract like terms, and we have a couple of pairs here. 3x plus 2x makes 5x, and the normal numbers of 6 plus 6 can make a 12. So we did a bit of like term adding and subtracting there. Well, just adding really. Like terms in algebra, any terms with the same letter and power, and normal numbers can be considered to be like with other normal numbers as well. So final answer there, 5x plus 12. Question 4. Simplify 2x over 3 plus x over 2. So when we're adding or subtracting fractions, we want to get the same bottoms happening, the same denominators. So we'll do that first. And 3 and 2 both go into 6. We can get an appropriate bottom number for this scenario by multiplying the original bottom numbers in the question. So if we multiply 3 times 2 and make 6, and make that our new bottom, then we can be confident that 3 and 2 can both go into it, because we kind of made the 6 by using the 3 and the 2. So let's put 6 like that and set it out there underneath each. Now we ask ourselves, what have we done to the bottom? And we must do the same to the top. For that first term to turn into a fraction with a 6 on the bottom, we would have had to multiply that bottom 3 by 2. So let's multiply the top 2x by 2. So let's do the same to the top there. So 2x times 2 makes 4x. Now let's have a look at the second fraction. It's turned into something over 6. We would have had to multiply the bottom by what? We'd have to multiply the bottom by 3. Let's multiply the top by 3 and we'll get 3x there. So I'm sure you're familiar with that process. And once we've got fractions that have the same bottom, the same denominators, we can add across the top. 4x plus 3x makes 7x. And in this case, we keep the bottoms the same. So we get a final answer of 7x over 6. Question 5. Simplify 4xy times 2xy squared. We multiply the numbers normally. So 4 times 2 is 8. We list any letters beside each other. And we also have to remember when we're multiplying something by itself, it makes a squared, such as a times a equals a squared. Letters wise though, you'll notice we have an x times an x. So that'll make an x squared. And in this question, we've actually got a letter, y, times a square already, which would have been a y times a y, that y squared part. So we've actually got a y times a y times a y in there, and a times a makes a cubed, so y times y makes y cubed. Another way to think about it is that that individual y in 4xy would have a power invisibly of 1. And when we multiply terms with indices, we add the indices. So some of you will have been getting y cubed by thinking of the y to the power of 1 and adding it to the y to the power of 2, or multiplying it really, and adding the indice part. So that's another way of thinking of that bit. So final answer there, 8x squared y cubed, and there's heaps of things that are happening there, but I'm sure you're okay. Question 6. Write an expression for the perimeter of the shape below. Rectangle here, and we have to remember that opposite sides in a rectangle are equal to each other. So really we've got a 2a on the bottom and a 3d on the left hand side as well, knowing the principles or the characteristics of a rectangle. So that's all the sides there. We have expressions for each of the sides. And perimeter is the total distance around the edge of any figure. So to get a perimeter expression here, we'll just add the 2a and another 2a and a 3d and another 3d. So we'll end up with 4a when we collect like terms there. The a's can join and the d's can join to make 6d. So we get a final expression there for the perimeter of that rectangle of 4a plus 6d. Question 7. Factorise 4x minus 12. We find the largest term that's common to both. We put this out the front of the brackets. We ask ourselves, what's the biggest thing that can go into 4x and minus 12? And I think you'll see that 4 can go into each. Then we fill in the brackets with whatever's appropriate. Now we want to be able to fill in the brackets so that if we expanded the brackets, we'd get back to our original 4x minus 12 in the question. So we ask ourselves, what would we have to multiply 4 by to get 4x? I think you can conclude with me there that x would be a good thing to have in the first part of the bracket there. Then we ask ourselves, what would we multiply 4 by to get minus 12? And we'll need a minus 3 for that. So then we'll check by expanding our answer like I was saying before. So if we expanded 4 outside of x minus 3, 4 lots of x would make 4x, and 4 lots of minus 3 would make minus 12. The last thing to double check is there anything common, still common, between the numbers inside the brackets? If there is, we'd look to take a larger term out the front in the very beginning. So that's a double check there. But we can factorise and then expand to see if we're correct in our factorising. Question 8. Factorise 3x squared minus 9xy. Find the largest term that's common. Put that out the front of the brackets. Largest term that can go into 3x squared and minus 9xy is 3x, can go into both. We want to fill in the brackets with appropriate terms. We ask ourselves, what would we want to multiply 3x by to get 3x squared? So to make a squared, we need another letter of the same type there. So we need another x. 3x times x is 3x squared. Then we ask ourselves for the second part, what would we have to multiply 3x by to get minus 9xy? So we'd need a minus, we'd need another 3 to make our 9 when we multiply, and we'd need a y to complete that term. So we'd have to have minus 3y for the second part of the bracket. We can check by expanding and see if we get back to the original. 3x times x makes our 3x squared, and if we multiply the front 3x by the minus 3y, we'll get 3 lots of minus 3 is minus 9, and x times y makes xy. So I'm pretty happy with that as a final answer. We'll just double check in the brackets to see if there's anything still common, but that's a pretty good answer there. Question 9. Simplify by factorising first. We've got 5m minus 35 on top, all over 15. Find the largest term that's common to both. We want to factorise first. Even the question told us to do that. So we'll factorise that top first there. The largest thing that can go into 5m and minus 35, we want to put that out in front of the brackets, that largest term. So 5 can go into each of those. So we'll look to have 5 out the front of the brackets, and we can write that 15 down the bottom in straight away there. We ask ourselves to fill in the brackets with appropriate terms. What have we got to multiply 5 by to make 5m? We'll need an m in the first part of the bracket. Then we ask, what do we multiply 5 by to get minus 35? We'd need a minus and a 7. Alright, so we've factorised the top there. Then we'll be looking to check our answer to see if we expand there properly. 5 lots of m would make 5m, and 5 lots of minus 7, we'll check that that makes minus 35. We're looking pretty good there. So we've factorised first, but we haven't done any simplifying yet. So we can cancel down numbers where possible, and we can cancel down letters where possible. We cancel down by trying to find a number and or a letter that divides into the top and the bottom of the fraction. So let's have a look at what we've got. We've got a 5 on the top and a 15 on the bottom. So I think 5 could go into the top and the bottom here. So we could divide 5 into the top and goes once, and 5 into the 15 and goes 3 times. It's good to write those little numbers there for the next step when we have to simplify further here. So that's cancelling down the 5s there. On the top we have 1 lot of m minus 7. We don't need to write that 1 in because 1 times anything is just itself. And on the bottom we just have a 3 from the cancelling down earlier. So that ends up being our simplified version after we've factorised. So 2 things there. Factorise first carefully, and then see if you can cancel down either letters or numbers or both sometimes. Question 10. If a equals 2, b equals 3, c equals 5, find the value of 3a squared plus 5bc. Let's substitute each letter with its number, the value given in the question, and then we'll calculate all the overall value of the expression. Alrighty, so we'll write out that expression there on the first line, 3a squared plus 5bc, and we've got the values for each of those letters, so we're going to substitute in underneath. So instead of the a, we're going to put a 2 because it told us that a equals 2 in the question. So instead of 3a squared, we're going to have 3 lots of 2 squared. And then we have a plus 5 lots of 3 because it told us that b equals 3, so we've substituted the 3 where the b was. And c equaled 5, so underneath where the c is in our next line here, we've put a 5. So you can see those blue numbers are the values that we were told in the beginning of the question. So let's calculate all that. We've got 3 lots of 2 squared. Now the 2 is getting squared, but the 3 isn't getting squared. So we'll square the 2 first and make 4. Multiply that by the 3 to make our 12. Be a bit careful with that. Depends on where the bracket is. If the bracket's around the 3 as well, that's a different story. Okay, for the second part, we'll have 5 times 3 is 15, times 5 is 75, making a final answer of 87 for the value of that expression when a equals 2, b equals 3, and c equals 5. So we sub in each of the letters, the numbers in the right spots to replace the letters, and then we see where we are there by calculating.